Hi everyone, how are you all doing? So today I'm going to go through a statistics S1 exam question. This one's about probability with some Venn diagrams thrown in. So here's the actual question. There's a lot there, isn't there? So what I'm going to do is I'm going to go through it a bit at a time, presenting each bit at a time, like so. And what you can do is either go through it with me, or you can actually do a screenshot, work through it yourself, and then play my video again, see the solutions. I'll leave it up to you, okay? Just as long as you get something out of it. So here we've got a factory producing shoes. So a quality control inspector takes a sample of 120 shoes and the Venn diagram shows the results. Okay, so here, A, so this circle here represents the event that shoes got defective stitching. So this one here, B, defective colouring, and finally C, it's got defective soles. And obviously the overlaps mean you could have more than one defect. This 93 means 93 did not have a defect, which is effectively what you want, isn't it? If you're manufacturing shoes, you don't want them to have defects. Okay. One of the shoes is selected at random, find the probability it does not have defective soles. So what's that? Defective soles is C, so that's those, isn't it? So does not have defective soles must be that one plus that one plus that one plus that one. 9 plus 0 plus 1 plus 93. Okay, so here that means you've got 103. So 103 out of 120 is your answer. Okay. Just in terms of notation, so the N of C means the number that I've actually got defective soles. So the number in C is 3 plus 2 plus 5 plus 7, which is 17. And then number that is not in C is 103. Okay. Just your answer needs to be a probability. So 103 out of 120. Okay. So that's the first part done. Next. Find the probability of A and B and not C. So A intersect B intersect not C. So A intersect B is going to be those two to begin with. Okay, you can see the overlapping circles. It's going to be those two. So that's A and B, but not C as well. So that is in C. So we want that one. So that's the one that satisfies all these, and it's 0. Okay, so there's 0 items there. So the probability is just going to be 0. And then the next one. Probability of A union B union C dash. Okay, so union means it could be everything in A or everything in B or everything not in C. So I start off looking at everything in A to begin with. So everything in A is those values there. So that's that. Then everything in B includes that and that. We don't count it again. Okay? So that includes everything in A or everything in B. And to also include everything that's not in C, you want that value as well. So basically it's everything there except for the number 7. So clearly it's just going to be, what was it, 120 in total? 120 subtract 7, which is 113. Okay, so 113 out of 120. Or you just add those numbers together if you get 113. Again, it's probability to leave it as a fraction. Next up, find the probability that the shoe has at most one type of defect. So at most one type of defect. So what does that mean? So it means you can have either 1 or 0 defects. Okay, so at most 1 means you're not allowed to have more than 1. So you look at it this way, the shoe has got either 1 or 0 defects. So let's look at the probability of 0 defects first of all. It's just that one, isn't it? Okay, so the number of 0 defects is just 93. And then let's have a look at the ones we've got 1 defect only. So 1 defect, so that's just that one. So just A is the defect, or just B is the defect, or just C is the defect. So those are the ones that have got just 1 defect. So 9 plus 1 plus 7, so 17. So this one or this one. So altogether that makes 110, doesn't it? So 110 out of 120 is your fractional value. Okay. For part E, given the selected shoe has at most one type of defect, find the probability it has defective stitching. So I'm going to go here for this next one, next board. So just a reminder of our answer. Okay. So notice this is a given question, which means it's conditional probability. So look out for the word given. Whenever a probability question says given that, it's a conditional probability question. And the conditional probability formula is that. So probability of A given B is probability of A and B over probability of B. In terms of wording, what actually is this? So we're looking at the probability of having defective stitching and at most 1 defect, given that it's got at most 1 defect. Okay. You'll notice that here we've got the the probability of at most one defect. So we've actually got the denominator done. It's 110 out of 120. Okay, so that's that one. We just need to work out the top. So from the Venn diagram, defective stitching. So defective stitching is A, isn't it? So it's got defective stitching. It's one of those numbers there. And it's at most one defect. So that's actually 9 there. And it can't be that, because that's 2 defects, that's 2 defects, that's 1 defect. So it's just going to be 9 for that one. So 9 out of 120 over 110 over 120, it's going to be 9 over 110. Okay. Alternatively, you don't need to use the conditional probability formula. When it says, given that the shoe is at most one type of defect, we saw that there were 110 that had one type of defect. So altogether, you deal with 110 shoes. Okay, because you're looking at all the shoes that got at most one defect, you're looking at 110 shoes. You're looking at those shoes there, effectively. Okay, those are the 110 shoes you are considering. Now, from these, which one has got defective stitching? That's the one there. So that one, 9 out of all these. So 9 out of 110. Okay, so you could do it without actually considering the formula if you wish. This one, so random variable x is the number of events A, B and C that occur for a randomly selected shoe. Find E of x. When it says E of x, you've just got to remember how to do this with these probability distribution questions. So expected value of x is sigma x times probability x equals x. What does that actually mean? It means you need to have a probability distribution table like this. Okay? So draw up one of these, what I do anyway to answer this because I find it helps you. And you've got either 0, 1, 2 or 3 defects. Okay? We saw already that the probability of having 0 defects is 93 out of 120. Or just work it out again, of course, 93 out of 120. Yeah? Probability of having 1 defect is going to be those 3 there, so that's 17 out of 120. Again, we saw that earlier. Probability of having 2 defects is going to be that one, that one, that one, which is going to be 8 out of 120. And then finally, probability of 3 defects, that one there, 2 out of 120. So that's your probability distribution table. Back to this. So to work out your expected value, you're going to do that times that, plus that times that, plus that times that, plus that times that. That's essentially what this formula means. The sigma means you add those together. You do a summation of that times that, plus that times that, plus that times that, and so on. So you just got to work out what that actually is. That turns out to be 39 out of 120. Okay? And that is it. I hope you got something out of that. Hope it was useful to you. Thanks for watching.